How's it going, everybody? I want to give everybody a quick heads up and update as to where we are at in the certification world. If you checked the title of this video, you know that I passed the CCNP service provider exams. So we are done with those and we are ready to go into the next round of preparation. For me, that is service provider CCIE. Now, some of the things that I wanted to cover about the 4 exams as a whole to try to give everybody a honest, unbiased opinion as to where I'm coming from on these. Now, like I've mentioned in previous videos that I've done for this, the one big thing that I want everybody to be cognizant of is I'm taking these exams as a CCIE in a different track, not as a CCNA, right? So I'm taking these exams with a much higher level of understanding than the average engineer. So for those of you that will be watching the I&E videos that I put out, which hopefully the next couple weeks they start getting released, I want everybody to keep in the back of their minds that when they're taking the exams, the reason I pass exams typically on the first shot at a CCNA or CCNP level is because I have a lot of back-end knowledge that helps me determine what question is more likely the right one to answer with. So, not trying to show off when I talk about passing an exam on the first shot. There's probably a pretty good reason why I do that. Now, I did my best to build the exams in the best way I thought they needed to be delivered, and I built the videos out in a way that would help you build your understanding from the ground up, because I assumed that nobody knew the technology before we got into it. So that's why I did an overview video of what was going on, what multicast is, why you would use it, things like that, and then I moved it into the next level of how do you roll it out, how do you work with it, how do you troubleshoot it, things like that. So that's one of the things that I wanted to get out front right away is keep it in the back of your mind. And I try to, in all 4 exams, one of the things that I tried to keep at the back of my mind was, what if you don't have the base understanding that I have? What if you're a CCNA in service provider or a CCNA in routing and switching, and then you all of a sudden you find out you're working for a service provider now and you need to be well versed in the SP side of the house? How do you make that transition to that side? Well, you need to start out with the base foundation understanding, right? That's with any track. Very first thing you want to do, go to Cisco's website, download the blueprints, read through the blueprints, go bullet item by bullet item by bullet item. And that's the best way to gauge your preparation. If you Google something or if you look something up, can you, off the top of your head, rattle off what that technology is about? If you can't, that's a good way to gauge your readiness. And I usually do it in a 5-step approach. The very first thing that I do is, do I even know what is that technology? So when I first started learning about layer 2 VPNs with VPLS, I knew it had something to do with multiple sites being able to talk to each other from a layer 2 perspective. Beyond that, I didn't know anything about it. I know a lot more about it now than I did before, and some of the advanced capabilities that it can leverage, but that was the starting point. Then it got into, well, what is it? How does it work? Why would you use it? Where would you put it? And what is the business driver behind it? If you can answer those 5 questions in a relatively, you don't have to put a lot of thought into it, it's more like off the top of your head, then you can sufficiently say you have a base understanding, a CCNA level's understanding of how it works. Now for CCNP, it's a little bit more involved than that. You have to know some of the more in-depth aspects of it and what it comes into play. So that's one of the things that really needs to be understood as you're going forward. Now, one of the things that I'm doing in this video here that I haven't done in the past is I actually have a semi-live audience. And this live audience consists of a couple of friends of mine that are, they come from a couple different backgrounds, if you will. So they have added in some commentary here that I am actually going to leverage here in this video. I'm going to do some live Q&A in this video and go from there. If you have any questions that you have after this video is posted, feel free to drop a line. So the very first question that comes in here is, do you think I'd benefit a great deal from the SP content as it relates to the enterprise? Say WAN edge peerings for MPLS, L3 MPLS VPN services. I've always wondered if I could benefit there because I thought SP would only help me if I were working on the SP context. Okay, that's actually a really good question because there's a lot of, let's qualify this real quick. L3 VPN services. Okay, what is an L3 VPN? Well, an L3 VPN is going to be your routing with the provider, right? So you're not doing IPsec or GRE or DMVPN or anything like that where you're routing over the provider. You're routing with them, right? So you're going through their core. Whether or not you see them or not is up to them. What I mean by seeing them is, do you see the individual hops through their core? You can, depending if you see MPLS labels, you're seeing their core, right? Well, in that particular instance, that's just getting you from your site to the remote site you're trying to peer with. Now, L3 VPN is just a reachability service, if you will. There are other services you can run on top of that, like you could run Multicast if you need to be able to advertise video from your headquarters site down to a bunch of remote sites. You know, you can run. There's Multicast is its own animal inside of L3 VPN service, so I'm not going to get into the details of how that could come into play. But what it really boils down to is, let's say you reach out to the provider and say, okay, I need to know what your QoS capabilities are. I need to make sure that I am marking my traffic the correct way on the WAN edge on your connection to the provider. Am I traffic shaping down to my committed information rate? Whatever the speed is that the provider has agreed to run with you at. For instance, if your committed information rate is, let's say your access is gig, but you're only paying for 100 megabit, your CIR is 100 megabits per second, right? So you can only send 100 megabits per second into the provider. How you break that traffic up really depends on the provider's capabilities. AT&T, Level 3, British Telecom, there's a lot of different providers out there that do L3 VPN service. It's really up to you to talk to them to see what their capabilities are. Now, one thing to keep in the back of your mind when you differentiate between Layer 3 and Layer 2 VPN, you run into some characteristic issues with the type of QoS you're working with. So in Layer 2, you have the class of service bits. So you only have 3 bits to play with in the Layer 2 header. In the Layer 3 header, you have 3 as well with the type of service, but you could also map those directly over to your DSCP, which gives you 6. Gives you more range of capacity, but it comes into play with your with whatever the provider supports. So if the provider doesn't support DSCP 41, you have to keep that in the back of your mind. You can't mark that traffic as that. So it's one of those things where it's good to know their policies. Another thing that I'll bring up is if you're multi-homing. If you're multi-homing, if you're dual home, whatever the case might be. So let me classify this real quick. You have single home. One router, you're connecting to one peer on the provider side, right? If you are dual homed, you are connecting your single router to 2 PE routers up on the north side, on the provider side. How you break that out, you could be 2 routers on your side, 2 routers on their side, but typically dual homed means you are connecting 2 peerings up to the provider. Typically they're going to diversify the peering. Then you have multi-homed, which means you're connecting to 2 or more ISPs, AT&T and Level 3 for instance. How you split that up is up to you. So the provider is just going to get you connectivity from your WAN edge to your WAN edge. That's what their job is to do. How you route through their network, they really don't care most of the time. You can get kind of fancy with route target import export peerings where you can do kind of like a central services VPN, or you can do what's common in the L2 side of the house of E-tree, where you do like a rooted point to multi-point, where you say that router 1 is going to be your root and routers 2, 3, and 4 are going to be your spokes. And routers 2, 3, and 4 won't be able to talk to each other. Kind of like a hub and spoke design if you were going to deal with, like, say, phase 1 DMVPN. Something along those lines. Now the other question here, and I hope that answers your question, but that's basically the idea behind it. There's a lot of, at the moment you say L3 MPLS VPN services, you have just brought out a very large onion and cut it in half, and I look at all the individual layers of that onion, and I can go into detail into almost all of them, which I don't want to bore anybody. Says the other question is, you mentioned multicast. What's the level of understanding one should have going into the service provider track on multicast, BGP, and MSDP. I've been through the IE RNS content and preparing for the lab. How much more involved is MPLS within the SP track? I'd say a good solid understanding of enterprise multicast will definitely serve you well inside of the SP multicast. And let me qualify that as well. So multicast itself is there's two flavors. You have the link local multicast, which is what your IGPs use in order to find peers. LDP does the same thing, things like that. Where you get into routed layer 3 multicast is probably where you're coming from on your question. That is having a solid understanding of how enterprise multicast works will pay off in spades for service provider multicast. And let me break that down just a little bit further. There's two flavors of multicast. You have dense mode and sparse mode. Dense mode means you don't care who gets it, you're just sending it everywhere. Because remember, multicast is UDP. It sends it out all the time. There's no way to prove that the end user or the receiver actually got the data. You're just sending the data blindly, right? Well, the multicast traffic is going to use an MDT or multicast distribution tree. The dense mode forms a connection from whoever the source is and peers it up to wherever the receiver is, and it gets flooded everywhere. Right? Well, actually, anywhere dense mode is configured, right? That's where the tree is going to get built. That's where the multicast packets are going to flow. Sparse mode is the more scalable variation of that, to where it goes from the implicit join, which means that you're going to get it whether you want it or not, to the explicit join, which means in order to receive it, you have to join a group, which is where in sparse mode you get into the rendezvous point. Think of the rendezvous point as kind of like a dating service, where I'm going to steal Denise Fishburne, I'm going to steal her example, where if I'm here in Milwaukee and I have a friend in, say, Nashville, and we want to get together, and the dating service or the rendezvous point is in New York, well, I'm not going to go to New York to meet this person. I'm going to go right to Nashville, right? So the key factor here is knowing the shortest path switchover. I don't want to go down a rabbit hole on multicast, but understanding the enterprise aspect of it is going to be extremely beneficial. So again, dense mode means you get it whether you want it or not, and then you have to prune off. Sparse mode means you get it only if you have asked for it. And then you can go the shared tree, which means that you go through the rendezvous point all the time. And then you also have the shortest path tree, which means you bypass the rendezvous point and go right to from the source to the receiver. Now, let me bring that into the SP side of the house. If you're going to be doing multicast in the SP core, you have the internal multicast core or multicast, and then you have the VRF aware overlay, PIM GRE overlay between the customer sites. Within inside of the core, you're going to have the default MDT, which is going to be using your dense mode style, which means everybody's going to get it whether they want it or not. The moment you go to the data MDT, you are leveraging the capability of sparse mode, which means you have to set up source-specific multicast inside the core, IP SSM default, and that's going to allow all of your PEs to join each other and be able to have a shortest path tree from you to them, wherever they are in the network. What that's going to leverage you to do is it's going to be able to take that data coming in from a customer and then shoot it across the SP core transparently to the other remote end. That means that I can have two specific groups. I could have, say, 1.1 or 224 1.1.1 and 224 2.2.2, right? They're two different multicast groups. You join them, your remote sites, however you need them to join, and then you go about going through there. If you watch the very end of my Edge course, I walk you through how to do that. It's actually relatively simple in how it goes through, but that's kind of the idea behind it. So with the default MDT, think of that as PIM dense mode, because everybody gets it whether they want to or not. The incoming PE that receives the PIM information from the customer sends it to all the other PEs, whether or not the PE attaches to the remote site that is actually going to be getting the data. The data MDT is more like sparse mode, because it only sends the information to the remote end that actually needs the data. So I hope that kind of clarifies that one. There is some correlation behind them and how they map to each other, but it's important to understand how that comes into play. Another question is V6 used a lot heavier in this track as compared to some of the others? My answer to this one is if I'm any network engineer, especially if you're dealing with routing and switching or service provider, security, data center, I would say IPv6 is going to be something that I would start learning from day one in your career till to the end of your career in the IT industry. It is not as widely deployed as IPv4, but it is quickly gaining traction. There are some services that only will work with v6. For instance, now I'm not a Microsoft engineer, so guys, don't beat me up or tell me I'm wrong. Clarify if you'd like. But when you deal with a technology known as direct access with Microsoft, it leverages IPv6. How much IPv6? I really don't know. I would be learning IPv6 as at the same time you're learning IPv4. So it's going to be something that I would definitely understand from the gate. I do cover IPv6 repeatedly through the course. I cover 6 VPE, 6 PE, IPv6 multicast, IPv6 routing. I go into some of the details to how it works. Now, if you want to learn IPv6 from the ground up fundamentally, my best advice to anybody would be to start off with understanding what the address types are, where they're used, how the address is broken down. And then I would start off with knowing how to configure it, how to turn it on iOS. And iOS is not on by default, so you have to go and type in IPv6 unicast routing. In iOS XR, it's on by default, so you don't have to do anything. I don't know if it is for Nexus, you might have to enable it. So from that perspective, that's one aspect of it. I do know that ASA supports it as well. I'm not sure beyond that I know it's supported in the wireless space. How much, I really don't know. But I would learn it from there. The only one that gets a little bit hairy when it comes to IPv6 once you've gone past the core understanding of v6 is NAT, or I should say there's a couple. NAT and then multicast. There's some things in multicast like embedded RP, dealing with the PIM variations of v6. You move away from IGMP and you get into MLD, things like that. There's some v6 specific things, and I would hit those once you've gotten into that topic domain. When you start learning multicast, that's an aspect I would focus on. Do you think I'd benefit a great deal from the SP content as it relates to the enterprise? Actually, I think I already. Oh, yep. Sorry, read that one. Okay, so one of the questions that I didn't, was a bullet item, was SP track on multicast BGP and MSDP. Well, let me bring into capability what multicast BGP and MSDP, the variations between them. So MSDP is designed to connect two remote sites in different autonomous systems together to be able to connect with each other. Typically, MSDP is used in conjunction with the technology known as Anycast RP. And you might be like, well, what's Anycast RP? Anycast RP basically is two rendezvous points that share the same IP address, and that IP address is advertised into IGP, which, if you understand how multicast works, PIM requires that a IGP be used. That's how the shortest path, the loop-free topology is built for multicast. Well, Anycast RP, Anycast RP over here, this guy could be used as the source side connection, and this one over here could be used as the receiver. Well, if the sender starts sending data to the first RP, the second RP is not going to know about that, right? So MSDP is going to be used to connect those two to what they refer to as a source active message. So the sender RP is going to send a message to the receiver RP so that that rendezvous point knows how to get the data to the receiver and vice versa. So these are things that come into play. Multicast BGP can be used in the same respect to advertise that information across between both BGP domains. Do I think there's one benefit over the other? I don't believe so, but when you get into the SP core, multicast MDT or the IPv4 MDT is going to come into play for advertising that information into BGP. So there's some correlation. If you follow me into CCIE service provider, I will be covering that in blog posts as we get into multicast. I'll hit all those bullet items. So stay tuned for that one. Let's see here. I've been through the IE RNS content preparing for the how much more involved is MPLS within the SP track? A lot more. Oh my God, I basically went down the rabbit hole to a certain degree with MPLS and CCNP. I covered a lot more than I really needed to, but I'm glad I did because there were some questions on the exams that I got hit with that if I wouldn't have covered them, I probably would have had a hard time with. And actually, that brings me to one of the questions or one of the points that I wanted to bring up here. But I want to get the questions out of the way because I know the guys that are watching here have a limited amount of time. One of the things that is big is one of the things that I recommend you do is if you're going to watch my CCNP Surface Spreader courses or videos, watch all 4 of them in succession and then go sit for your exams. The reason why I say that, or if you're planning on taking the exam, that's the methodology I would leverage. The reason I say that is because if you follow all 4 courses and you go through the material and you lab it up, you test it out, make sure you know you understand it, you'll be that much better off to take the exams. Because there was stuff that I saw in Route that was brought in from Core and Edge, and kind of the same thing from Edge. I saw some stuff from Core that I was able to leverage the information. I won't go into detail what they were, but when you go take the exams, you'll know what I mean. So I would recommend you watch all 4 video courses, take as much notes as you need to, and then go take your exams independently. And then I would fall back to say Route again once you've gone through all 4, and then watch the video course again, just so you can reinforce anything that you might have forgotten or what have you, because you're looking at around 100 hours of video and about 200 of them. So it's a lot of material to cover, but I needed to cover it well enough that you wouldn't be left like, what is this guy even talking about? Because there's a lot of information to cover. Now, the one cool thing for anybody that's going from CCNP RNS to CCIE RNS is this is a stepping stone from CCNP to CCIE, because I cover a lot of the stuff that's on the CCIE blueprint that the CCNP doesn't touch. I think Cisco should come out with a 4th exam for CCNP routing and switching that is geared towards the way that Service Provider is done, an advanced route, which will bring in an extra BGP, multicast, and I think they should have they should rope in some QoS and some MPLS. Not a lot, because you're not going to get hit that heavy on the IE with this. It's going to be more or less, can you get a basic functionality for L3 VPN up and running? If you can do that, you're in pretty good shape for a CCIE. Now, not to say that you couldn't go any deeper so that you won't get hit, but you're not going to get hit with MPLS traffic engineering in the CCIE route switch exam. They're just not going to hit you with that. They could hit you with LDP authentication. They could hit you with, only advertise a certain label space for MPLS. But those are really, really basic commands, one-liners that you can throw in there. It's been a year since I've taken the lab, so I don't know what they're going to toss at you. And all 3 attempts that I took, I had slightly different variations of the exam. So you're never going to get hit with the same exam twice. It may appear so, but you're going to notice some nuances between the questions and where they want things to be configured and how. But it's your job to read through that and be able to infer what they're trying to tell you. EVPN. EVPN, or Ethernet Virtual Private Network, is kind of a unique animal all in itself. So since this is Service Provider focused, let me kind of qualify some things. So for those of you that are familiar with the Cisco terminologies, you have ATOM, you have VPLS, you have HVPLS, and things like that. ATOM is any transport over MPLS. It's point-to-point layer 2 VPN. You have VPLS, which is point-to-point to multipoint, or multipoint to multipoint, or any-to-any. And then you have your HVPLS, which takes your VPLS to the next level and kind of throws in route reflection, if you will, into the mix a little bit with BGP. There's a little bit more to it than that, but that's a real high-level overview of how the 2 come into play. Those are Cisco coined terms. If you're looking at the Metro Ethernet forum, you get things like E-line, E-LAN, E-tree, things like that. The Ethernet line, the Ethernet Ethernet local area network, the Ethernet tree. If you're looking at the IETF, you're looking at the EPL. the eVPL, the eTree. They all have similar naming conventions and very similar configurations. So if you hear Atom, it could be port-based or VLAN-based or Q&Q-based VPN, which means that if I'm doing port-based, I'm physically attaching the X-Connect at the main interface. If I'm doing VLAN-based, I'm putting the X-Connect at the VLAN level, at the .1Q interface. If I'm doing Q&Q, I'm doing a secondary tag, so .1Q10, second .1Q20. So there's different variations of how that comes into play. Ethernet VPN can be very scalable. There's a follow-up question to that one. Was it PBB, eVPN, Get VPN? Well, two different VPNs. Get VPN, or Group Encrypted Transport VPN, is designed to take the IPsec that's typically used with DMVPN, and instead of being multiple IPsec VPN tunnels, you have one, where you're connecting a group of connections together with a common encryption. What's the word I'm looking for? Not platform, but design, I guess would probably be the better way of putting it, where you're grouping everything together into one tunnel. Get VPN is actually, in my opinion, more applicable towards Lisp. And the reason why I say that is because with DMVPN, you're basically leveraging multi-point GRE, but you're not giving it any real elasticity with the respect of dynamics. So dynamics in the respect where I could have a spoke site that's got a VM, and then all of a sudden that spoke decides to vMotion that VM to site 2. Well, unless I have shut down that VLAN at that remote site, I'm still going to point all my traffic to that original spoke. Well, Lisp is going to allow me to update that information and move it to the secondary spoke, to where I'm going to say, okay, well, VM1 is no longer behind spoke 1, VM1 is now behind spoke 2. So that's where that kind of stuff comes into play. And that's one of the capabilities that really needs to be understood here, is the differences between them. So Get VPN is more of is an encryption capability. I would say that's more like your IPsec profiles at the DMVPN interface level. It's wave 2, if you will. PBB eVPN, that is hardcore service provider stuff. Only supported on iOS XR, so I do cover it briefly in Edge. And the reason I cover it briefly is because of the fact that it's very, very little support for it in XRV. You can do just the basic aspects of it. So let's qualify PBB. It's provider backbone bridging, or MAC and MAC routing, to where you are moving away from the VPLS, HVPLS capability and into the provider backbone aspects of it, which now you had the original VLAN. You could virtualize a device with a VLAN, right? Then you moved into Q&Q, which gives you went from 4096 to instead of being limited to 4000 VLANs, now you could encapsulate 4000 VLANs inside of another VLAN, which kind of was VXLAN pre-VXLAN. And then you get into VXLAN, where you are able to hide which is kind of like layer 2 VPN in a way, where you are going from 4,000 instances to 16 million with the VNID, and that's a capability exchange that needs to be negotiated between your endpoints. It's similar in a lot of ways to layer 2 VPN because of the fact that it uses a bridge domain, and you're basically using it to bridge layer 2 over layer 3. So ACI NSX uses this to get connectivity between your in ACI between your leaf switches with your 9Ks, and then in NSX between your VTEPs with your host 1 and host 2 in ESXi. So you're able to bridge things around. You can put two different VMs that are on two physical hosts in the same logical switch, and then you're able to switch between them pretty seamlessly. PBB is going to give you the flexibility of leveraging one, and I don't know much about it, so I'm going to have to kind of stay very high level because I don't want to speak out of term on something I'm not as familiar with. But PBB takes that to the next level. So kind of like VXLAN is taking your .1Q and Q, or your Q and Q tunneling, it takes that to the next level. Like VXLAN, you get 16 million instances of per tenant. It takes that to the next level. so you can take it and be as scalable as you would like with Mac and Mac. I actually got, I'm going to be covering that quite heavily in the near future, but there's limited support in iOS XRV. If you want to take a look at how that works, you're more than welcome to do so. One of the things that's interesting about PBB is it's the majority of the main configuration is done in XRV. However, in the CSRs, you can use the excuse me, the EVPN address family, and the CSR 1000Vs can be used as a route reflector between your PBB endpoints. Well, because you have your bridge, your BEBs and your BCBs, which is kind of how HVPLS works. Where in HVPLS you have your user-facing PEs, which connect to your customers. The UPEs connect to your NPEs, which is effectively your core. So think of it kind of like a multi-area OSPF, where you have your area 0 is your HVPLS, your NPE core, and then you have a bunch of UPEs, which could be separate OSPF areas. And then they all need to connect back to the OSPF area 0 or your NPEs, and then there is split horizon set up between them so that you're going to be forwarding towards a UPE that you need to connect to. Kind of same way in the switching world works. You're not going to be sending data out the same interface you received it on because it's likely the destination is not on the PE that you came from. PBB kind of takes that capability, and instead of using the HVPLS hierarchy, you leverage the capability of the Mac and Mac. And I'm going to have to digress from there because I don't know much beyond that point. It's an area that I haven't spent as much time in, but I will be hitting that topic in the near future. So stay tuned for a blog post on that. But that gives you a high-level view of how and the reason why I laid things out that way. When will your CCNP Service Provider courses be available? I don't know yet. They've been uploaded to INE now for a little bit of time now, and they were just waiting for me to give them verification that I had passed CCNP Service Provider. I don't know where they are post-production wise, but I do know that here in the very near future, I'm expecting something as early as next Tuesday that you should see at least the first video course being released, if not the next couple Tuesdays before the end of the year, or sometime January 2017. That's one of my guesses. Somewhere in there, you'll start seeing stuff released. I don't know if they're doing it in waves or if they're just going to do a 4-course dump and here you go. It's really hard to say right now, but I did talk to them just recently and they said they were in good shape. I've got some very minor stuff that I have to finish up, like I have to do some administrative details. I won't bore you guys with the details, but just to give you a quick recap of what we've covered so far, watch all 4 video courses at one time in order: Route, Advanced Route, Core, and Edge, and that will allow you to take questions that I saw in Route that would have been nice to know about in Edge, that you'll be able to correlate the Edge questions in because of the fact that you'll be seeing those details. Beyond that, that's pretty much it. I mean, it was a lot of fun to put together. I learned a lot of stuff. I was able to take a lot of stuff that I knew from Route and Advanced Route for my IE stuff. I was able to pretty easily bridge that over. I actually had to slow down a lot in Core because I had never really dealt with MPLS traffic engineering, and I had to really think of how I was going to roll out QoS. QoS is pretty heavy in the Core exam, and I really wanted to sit down and understand what it was that I needed to have in play in order to get that to roll out. It's not difficult in that respect, but QoS is one of those technologies and those feature sets that just knowing what traffic shaping isn't really going to be very beneficial to you, because you have to understand how class maps are built, policy maps are built, and service policies apply, and there's multiple aspects of it that you could bridge into it, because the moment you start talking about the diff-serve model and how each hop can dictate what traffic handling can be done on a per hop basis, that changes your forwarding paradigm, how you handle things on a per hop basis, where inserb is kind of like with MPLS traffic engineering, where you use RSVP to reserve the information through the network. So you know whether or not that tunnel is going to come up, whether or not the resources are available or not. So I cover all these details in the courses. Definitely check them out if you're interested in doing so. Drop a line here in the video if you want to know more about that type of stuff. Comments are welcome. Keep them clean. I definitely don't want anybody getting, chewed out or beat up because of something I've said or a comment that somebody's made. If you're nasty about stuff, I'm just going to delete your comment and I'll answer the questions. If you think you can answer the question, by all means, try to go ahead and answer the question. If I think it needs clarification or a little bit deeper of an explanation, I'll go ahead and handle those on a case by case basis. I can't talk, as you can tell, at the end of the day here. I had a lot of fun putting the course together, like I said. One of the things that I want to let everybody know is I am actively pursuing SPCCIE, and I have. At first, I was going to knock out layer 2 VPN, layer 3 VPN, and kind of work my way up the stack from there. Well, you kind of get burnt out after a while of hitting the same technology for a month straight. So I am actually hitting, well, bear with me here, I'm hitting Lisp, Unified MPLS, ILAN, VXLAN, MGRE, and then I'll circle back to Layer 2 VPN. A lot of really cool stuff is coming out. I'll be doing blog posts on all of those technologies. If you're not familiar with my blog posts, check out theriker.blogspot.com. I'll put a link in the description. Please hit that up. It's going to go into a lot of detail. It's going to be classified CCIE SPv4 simply for the fact that these are all technologies that I'm going to be putting into the videos as I go forward and the blogs and go from there. But again, I'd like to thank everybody for their continued support. We're quickly approaching 5,000 subscribers. I never personally thought we'd ever get near that. This started off as just a way for me to teach stuff out there to validate my learning and for people to call me out if I was wrong. Very few people do because I normally know what I'm talking about. But it has actually enabled a lot of people to get to know me. Anybody that knows me will more than likely tell you that the person you see on the videos is the person you get outside of the video. There's nothing fancy about me as a person. So if you have a question, comment. If there's something you are studying on that pertains to routing and switching or service provider, or even has something to do with, like, say, the data center track, like VXLAN, stuff like that. If you have a question or would like to see something covered that I might be able to squeak in, that isn't going to take me 6 months to go learn, drop a line. Put a comment in the video down below in the comments, because then that's going to be something that I may not have thought about. I'm covering a lot of topics here in the next 6 months that I think a lot of people are going to benefit from. But it's one of those things where I don't know what needs to be covered until somebody throws a bone and goes from there. There's actually quite a few things that I'm looking at covering. Like there's OTV that I'm going to be hitting because it's a data center interconnect style connection. So there's lots of cool stuff that I'm going to be hitting as we move forward. And like I said, if you have an idea or a suggestion, drop a line. You never know. It might be covered in a blog post in 3 months from there. I respond to you, and I might ask for more details. Okay, what's the use case behind it? So I can kind of morph it to help you out. The blog post might be inspired by your question and geared towards your response. So it might actually be worthwhile for you to drop the line and then have me go into the details on it. Again, no, unless it's like hardcore ASA or hardcore Nexus, where I'd actually have to go get like a 9K for ACI. Probably not going to get covered, but if it has applicability, I'm trying to keep things as open as I can and go from there. So again, thanks to everybody for their support. If it wasn't for you, this channel wouldn't have grown to the size that it's grown to and stuff like that. So until next time, you guys take it easy, be nice to each other, and keep it up.